오빤 강남스타일 강남스타일 오빤 강남스타일 강남스타일
Good day, everyone. I am Ramona Angie Ramones.
And I am Jason Carlo Puerto.
And welcome to the Makati High School Chemistry Project. Our project for today is what we call the titration. By the way, Parker, what is titration?
Titration is the process of knowing the unknown concentration of a solution.
So that's it. The objective of this project is to prepare a standardized sodium hydroxide solution
To
and
determine the acetic acid content of vinegar.
so let us now start, and here are the materials that we're going to use.
That's why
Everyone. By the way, my name is Julius Francis C. Mamba,
And my name is Jan Luis Benito.
and these are all the things we need for the titration. We need volumetric flask, rubber stopper, graduated cylinder, funnel, beakers, spoon, and steering rod.
And at this side, we have the analytical balance, 2 Erlenmeyer flask, the sodium hydroxide flakes, the vinegar, the iron stand, the burette, and the iron ring.
Go.
And now we already have 2 grams of sodium hydroxide. We will use this large beaker so that the sodium hydroxide will dissolve faster, for it has a large surface area. First, we're going to put a little amount of water. Then, add the sodium hydroxide, which is 2 grams. Then stir it until it dissolves. Now, the sodium hydroxide has already dissolved. Now we're going to use this volumetric flask, which has a 500 ml mark, so that we can have a 500 ml solution of sodium hydroxide. We're going to transfer it with the use of funnel. Then add water until the 500 ml mark.
We are now here to prepare the aligate of the solution. First, we have to measure 25 ml of the acetic acid or the vinegar in the graduated cylinder. So the 25 ml acetic acid will be transferred to the beaker. To create the 250 ml solution, we have to put water until it reaches the 250 ml mark. Now we have a 250 ml solution of acetic acid. Now we have to get 50 ml of the same solution and transfer it to the Erlenmeyer flask. We have to measure it using the graduated cylinder. 50 ml solution will be transferred to the Erlen Mayer's flask. And in the new solution, we will add 50 ml of water. Let us measure the water again using the weighted cylinder. We have to put the water in the Erlen Mayer flask. This is the phenolphthalein solution, and we have to put 2 drops of the phenolphthalein solution in the same solution. As you can see, we now have here the burette. The burette includes the titrant, which is the 0.1 molar sodium hydroxide solution. Now we also have the acetic acid solution. We are going to titrate the acetic acid solution in order to determine the percent of acetic acid present in the vinegar. We are going to put the sodium hydroxide solution . And now, as you can see, the acetic acid solution is slowly changing its color. And now, the acetic acid solution changes color to pink. This is what we call the end point.
Hey, I just met you, and this is crazy.
Good day, everyone. Today, I'm going to explain to you the first step, which is the computation of the annual sum. To identify annual here is the measurement we get of acetic acid from some commercial vinegars. The 50 ml here is what we get from a 250 ml, which is the combination of water and acetic acid, which is equals to 5 ml, that is the volume of acetic acid used as sample.
Good day, everyone. Now that we are done with the process of titration, we are now going to compute for the mole of the acetic acid. The volume of sodium hydroxide required to titrate is equal to 35 ml. The equation that we are going to use is N is equal to M times V. The molarity of sodium hydroxide is equal to 0.1 moles per liter times the volume, that is 0.035 liters. The product is equal to 0.0035 moles of the sodium hydroxide. The chemical equation that we use is sodium hydroxide plus acetic acid is equal to sodium acetate plus water. To make sure that the equation is balanced, the ratio is 1:1, since 0.0035 moles of sodium hydroxide is equal to 0.0035 moles of acetic acid. Now that we've computed the moles of the acetic acid, that is equal to 0.0035 moles of acetic acid, we are now going to compute the mass of the acetic acid. 0.0035 moles of acetic acid is multiplied with the formula mass, that is equal to 60 grams, divided by 1 mole. The product is 0.21 grams of acetic acid. That is the mass. Mass of the sample is equal to density of acetic acid times the volume of the sample. 1.0492 grams per ml is the density multiplied to the volume of the sample, that is equal to 5 ml. The product is equal to 5.2146 grams. The percent of the acetic acid is equal to 0.21 grams divided to 5.2146 grams times 100. The percent of the acetic acid